Question number 3. The depth of seawater at a location can be modeled by the function h that satisfies the differential equation. dH dt equals this thing, where ht is measured in feet and t is measured in hours, so feet and hours, after noon, so t equals 0. It is known that h0 equals 4. So this is an initial condition. Question A. A portion of the slope field for the differential equation is provided. Sketch the solution curve for y equals ht. That goes through point 0 to 5. So 0 to 4. 0 to 4 is here. And the trend here is it is increasing here, and it stops about between 3 and 4 or 3, and then it goes downwards again. So let's graph that out. It goes to 3, it slows down, and then it goes down. So this is the curve, so it must pass through the point 0 to 5, 0 to 4 here, 0 to 4. And it should follow this trend. Okay, question B. For t equals 0 to t equals 5, it can be shown that ht is larger than 1. Find the value of t for 0 to within this interval at which h has a critical point. Determine whether the critical point corresponds to a relative minimum, maximum, or neither of the depth of seawater at the location. Justify our answers. So there are two ways to do this problem. So first we can use the first derivative test. dH dt is giving us this, which equals to 1 over 2. Okay, so critical points can be found when h prime t, which is equals to dH dt, equals to 0. So let's find this value, this function actually. This function equals to 0. What is the t value? Okay, so this function is defined from 0 to 5. So let's see. 0 to 5. There's h minus 1 and cosine t over 2 equals 0. Okay, we can ignore that 1 over 2. Okay, so by finding this, h equals to 1. But it can be shown that ht is larger than 1. So this answer is omitted. Cosine t over 2 equals 0. This equals to t equals to pi. Because cosine pi over 2 equals to 0. Okay, so t equals pi. There's a critical point. Okay, now we have to find whether the critical point is a relative maximum, minimum, or neither. Okay, so let's first do the first method, which is finding those intervals. So the general interval is from t equals 0 to t equals 5. There's a critical point at t equals pi. So let's break that interval into two parts. 0 to pi and pi to 5. Now let's substitute a value from these two intervals and find which one is positive, negative. Okay, so dH dt piles is about 3.14, so let's pick 1. 1 doesn't work, h minus 1 equals 1, so let's pick 2. 2 is 1 over 2, 2 minus 1, okay, so it's 1 over 2. Cosine 1 is positive, so this is a positive number. So dh dt2 at this interval equals to is larger than 0. It's larger than 0 at this interval. And what about at the interval pi and 5? Okay, well, we pick a value between pi and 5, say 4, then it will be smaller than 0. So the dh dt changes from positive to negative at pi. So there's a relative maximum at pi. There's a relative maximum is when dh dt changes from positive to negative. Relative minimum is when dh dt changes from negative to positive. And neither max nor minimum is when dh dt does not change any sign, so it's from positive to positive or negative to negative. The graph here can simply describe this. So dh dt is the slope of the curve. It is increasing, so positive means increase. dh dt is positive, this is increasing, and dh dt turns negative, goes decreasing. So there's a relative max here. Minimum changes from negative slope to positive slope. There's a minimum here. Neither means that it changes from positive slope. It does not change anything, so it changes to again positive slope. So there's neither a maximum or minimum here. So in this case, it changes from positive slope to negative slope. So there's a relative maximum at t equals pi. So we can write at t equals pi, there's a relative maximum at h. Okay, so the second method is using the second derivative test. So we're given that dh dt equals to this function. We can differentiate it again to find its double derivative. So now we differentiate it 2 times. It will become let's see, 1 over 2 h minus 1 cosine t squared. So we differentiate cosine t squared, it becomes negative sine t over 2 times 1 over 2. Okay, plus using the product rule, we get that cosine t over 2, and we differentiate h minus 1. So note here that if h is a function, and if we differentiate h minus 1, we have to use the chain rule. So if we first differentiate h minus 1 with respect to h, we would get 1. Then we have to differentiate with respect to t, so we get dh dt. Okay, so times 1 to make that clear. So h minus 1 differentiated with respect to t becomes dh dt. Okay. Now to find if dh dt is a relative minimum maximum or neither at t equals pi, we have to substitute t equals pi into the second derivative here. So at t equals pi, d squared h dt squared equals to pi minus 1 negative sine pi over 2 times pi over 2 times dh dt again. So dh dt equals to this thing, so let's write that out. Pi minus 1 cosine pi over 2. Okay, so is this positive or negative? So let's analyze term by term. Pi, so 3.14 minus 1 is positive. Okay, and negative sine pi over 2. So sine pi over 2 is 1. So negative 1. So this makes it negative. So this term is negative here. Plus 1 over 2 cosine pi over 2. This becomes 0. So we can cross this term out, leaving this term only. So now, because positive and negative makes negative, this term is negative at t equals pi. So remember that when a double derivative is larger than 0, it means that the function is concave up. And what does concave up means? It means this. It's a general term with an open a parabola facing upwards. So h is concave up, which means that at this point there's a relative minimum. And if the double derivative is smaller than 0, then h is concave down at that point. So something like this. And this has a relative maximum. We found out that at t equals pi, the double derivative of h is smaller than 0. So at h equals t equals pi, it has a relative maximum. So at t equals pi, there's a relative maximum at h. Okay, so the final question for question 3 is C. Use separation of variables to find y equals ht. The particular solution to the differential equation, so dh dt, with initial condition h0 equals 4. Okay, so dh dt is a differential equation, and we have to use separation of variables. So separation of variables. So we first write down the differential equation dh dt, and we have to find a way to separate like terms. So dt goes with t and h goes with h, and by this we bring h minus 1 with dh, and we bring dt up with cosine t over 2. Okay, so make sure to write out this step, and then we add the integration sign. Okay, we need to write down this first, then write the integration sign. So now we can integrate both sides. This will become natural log h minus 1 absolute value equals 1 over 2 sine t over 2. We would get this, yes, and then 2. Okay, and plus c. Okay, so we have to add the constant of integration in the final term. Okay, now we cross them out. This would just become natural log h minus 1 equals sine t over 2 plus c. And now we have to use our initial condition, which is h0 equals 4. Now if we substitute h to 4 and t to 0, we would get 4 minus 1 equals sine, and when t equals 0, so it's 0 over 2, which is 0. So sine 0 is equal to 0 plus c. So c equals natural log 3. So now we can substitute c back into our equation. Natural log h minus 1 equals sine t over 2 plus natural log 3. Okay, now we have to solve for h. We can't just leave it like this. So, exponent and natural logarithm properties would say that this is e. So, e to the sine t over 2 plus natural log 3 equals to h minus 1. So this means that simply log something, let's say x, plus y, because lateral log is log e to something. This means that we can rewrite this as log, you don't have to rewrite it, so it just equals to e to the yth power equals x. Okay, so this is the same for what we're doing here. E, so there's an e here, e to the sine whatever power equals to h minus 1. Then we just bring that 1 over, so we would get e sine t over 2 plus ln 3 and plus 1. We can further simplify this. So e sine t over 1 over 2 times e to the natural log 3 plus 1 power and plus 1. And e to the natural log 3 is just equals to 3. So it becomes 3 times e to the sine over 2 t over 2 power plus 1. Okay, so h equals 3 times e to the sine t over 2 power plus 1. And we have solved for h.